Hi, I'm Mark Barsamian. In this video, I'll be discussing tangent line problems and applications problems involving quotients. This material is from section 3.3 of the book, Derivatives of Products and Quotients. There is an applied problem in that section involving a quotient. It's example 6. But there is no discussion of tangent line problems involving quotients in section 3.3. There is an example involving a product, that's example 2. But a specific book example involving quotients is not really needed. We've seen tangent line problems in book sections 2.4, 2.5, and 3.2. All the tangent line problems are solved in the same way. Only the particular technique used to find the derivative varies. The corresponding homework for this video is this collection of 2 problems from section 3.3. Let's recall the derivative rules that we've learned about in previous videos. Our basic rules, constant function rule, power rule, sum and constant multiple rule, the various exponential and logarithmic function rules that we learned about in section 3.2, and then the product rule that we learned about earlier in section 3.3, and more recently the quotient rule, that the derivative of a quotient is given by that crazy formula. Example 1 is similar to 3.3 number 63. For this function f of x, find the equation of the line tangent to the graph of f at x equals 3. Our solution outline should be familiar by now. We start by writing down what we are going to be doing. We're going to be building this equation, which is simply the point-slope form of the equation for the tangent line. And remember, the approach we always take, we start by getting the parts that we're going to need to build this equation. We'll need to find that part, and that part, and that part. Now remember, this letter A, sitting right there, is the x-coordinate of the point of tangency. Well, that information is given to us in the problem statement. We're supposed to find the equation of the line tangent to the graph at x equals 3, so x equals 3 is the x-coordinate of the point of tangency. The next part we'll build is f parentheses a. Of course, since we know that a is the number 3, this means that we're going to find f parentheses 3. And that means that we substitute x equals 3 into the formula for f of x. And remember the meaning of the symbol f parentheses a. It's the y-coordinate of the point of tangency. Now the next part that we need to find is f prime parentheses a. Now that means that we have to find f prime parentheses x and then substitute in x equals a. So in other words, the next thing we need to do is find the derivative, f prime of x. So there's the result of the first step. We use the quotient rule to set up our derivative. We don't actually do these 2 derivatives in this first step. We just simply use the quotient rule to set up the form, and it tells us what derivatives we'll need to do next. For the next step, we're going to do those derivatives, but first I'll copy down all the stuff that's not going to change. Also, it's worth reminding ourselves that we should not make the tempting mistake. It's tempting to cancel 2x minus 3 and 2x minus 3, but you can't cancel because there is no 2x minus 3 in this part of the numerator. So 2x minus 3 is not a common factor in the whole numerator, so we cannot cancel the 2x minus 3. So we really have to go on and do the derivative without that cancellation. We start again by copying the stuff that does not change. Now in this left parentheses, we'll put the result of this derivative. The derivative of 2x minus 5 is 2. In these right parentheses, we'll put the result of this derivative. The derivative of 2x minus 3 is 2. Now we simplify. Notice that we have terms that will cancel. This 4x gets canceled by this 4x, and then we have 6 minus a minus 10, so that gives us a 4 in the numerator. So that's our f prime of x. Now remember, that is not the equation of the tangent line. That's not even the slope of the tangent line. The derivative is a function, a function that can be used to get the slope of the tangent line. Remember, the slope of the tangent line, the thing that we're after, is going to be going here in this line equation. That has to be a number. That's the slope. That's not what we've got so far. So far, what we've got is this function, this formula that can be used to find the slope. We'll get the slope in the next step. So we're ready to substitute in x equals 3 into our formula for f prime of x. Let's scoot up a little bit and see that formula. So there's our formula for f prime of x. We substitute x equals 3 in. And we get a result that f prime parentheses a equals the number 4/9. So again, note, the derivative is not the slope of the tangent line. The derivative is this formula, this function. That function can be used to find the slope of the tangent line. That would be called the derivative at 3. And that's the number 4/9. That is the slope of the tangent line. And that is the quantity that's going to go in to this formula for the equation of the tangent line. Okay, so let's remind ourselves where we are. So far, we've gotten the parts that we need to go into this equation. So now the next thing is to substitute those parts into the equation. A equals 3 will go there. F of a equals 1/3 will go there. And f prime of a equals 4/9 will go here. So I substituted those 3 numbers into the tangent line equation. So what we've got now is the point slope form of the tangent line equation. So what we should do now is convert this equation to slope-intercept form. And the way we do that is we solve for y. And the result is the equation y equals 4/9 x minus 1. Now notice that we have to be careful. We have a fraction, 4/9, sitting next to something that's not a fraction, the x. So I put the 4/9 in parentheses to be clear, and also I made sure to write the x up on the baseline of that fraction, not down on the floor, not down with the 9. Let's go on. Question B says, illustrate our result of A on the given graph of f of x. Well, let's recall what the question was in part A. The question in part A was to do this. Find the equation of the line tangent to the graph of f of x at x equals 3. So we've got the equation for that line. Now to illustrate that equation, we should draw that tangent line. Notice a couple of things that we've done are going to be useful. Of course, the x-coordinate of the point of tangency is that number, x equals 3. The y-coordinate is that number, 1/3. What else is useful? The y-intercept is -1, and the slope is 4/9. So our tangent line has to be tangent at the place on the graph where x equals 3. That's here. Crosses that grid line. And we can put coordinates on this point, 3, 1/3. There's that known x-coordinate of the point of tangency that was given to us, and then the y-coordinate of the point of tangency that we computed, and then we have to draw the tangent line. Of course, it's always a little bit tricky to draw a convincing-looking tangent line, but we have a bit of help. We figured out that the tangent line equation is y equals 4/9 x minus 1. That equation, that told us that the y-intercept for the tangent line is at y equals -1. So we know that our tangent line is going to have to go through this point over here. So we just need to draw a line that goes through those two red points. And we should label that line with its equation. And we should put the equation for the function on this graph as well. That's the end of that example. Let's go on. Example 2. This is similar to 3.3, number 93. Sales of a game are described by this function. S parentheses t equals 50t divided by the quantity t plus 4. Now in this equation, t is the time in months since the game was introduced. S parentheses t is the total sales. Now sales, that jargon, total sales, is used in different ways in different situations. Sometimes the word total sales means the total amount of money that you made from sales. That would actually be revenue. But in this problem, total sales is said to be in thousands of games. So in other words, the function s parentheses t is not describing the amount of money you get from the selling of the games. It's just describing the number of games you sold at time t, the total number of games that you sold by that time. And it's the number of thousands of games. Okay, question A. Find s parentheses 6. The result is that s parentheses 6 equals 30. Question B. Find s prime parentheses t. All right, so we need to find the derivative. Now remember that the derivative is t, not x. So when we find s prime parentheses t, we'll be doing d dt, not d dx. So we set up the quotient rule. We use the form of the quotient rule, and we save these derivatives to do in the next step. This derivative here, we don't try to do it in the same step where we set up the quotient rule. And this derivative here, we do those in the next step. Let's remind ourselves that we should not cancel the t plus 4. Remember why. It's because there is no t plus 4 in the right side of the numerator. So t plus 4 is not a common factor in the numerator. Now we make room for the results of those derivatives by copying down all the stuff that's not going to change. All right, the derivative of 50t is going to go here. That's going to be the number 50. The derivative of t plus 4 is going to go here. That'll be the number 1, because the derivative of t is 1 and the derivative of 4 is 0. Now we simplify. And there's our result. S prime parentheses t is this function. Let's go on. Question C, find S prime parentheses 6. We end up with the result that S prime parentheses 6 equals 2. Now remember how we did this. We substituted t equals 6 into the formula for S prime parentheses t. So we got this formula, and we substituted in t equals 6. Question D, write a brief interpretation of the answers from A and C. Brief interpretation. Now remember what that means. That means that we are supposed to explain what our abstract mathematical results. Remember, we have an answer in question A that was an abstract mathematical result, S parentheses 6 equals 30. And in question C, we have another abstract mathematical result, S prime parentheses 6 equals 2. To interpret those means that we have to explain what they tell us about sales of the game, because this function S parentheses t is a function that's serving to model an actual situation that has to do with sales of a game. So writing a brief interpretation just means explain what those abstract mathematical results tell us about sales of a game. Well, let's go back. Well, let's write the results from A. So those are the mathematical results from A and C. This should say C. What do they mean in terms of sales of the game? Well, we're told what the function S parentheses t means. S parentheses t is the total sales in thousands of games at time t, where t is in months. So an interpretation of this mathematical equation would be this. So there's our sentence. At time t equals 6 months since the game was introduced, a total of 30,000 games have been sold. So notice that our number 6 shows up here, and our number 30 shows up here, but also the units that go with those numbers show up in the sentence. T is 6 months, and the 30 refers to the number of thousands of games, because that was the explanation of the original function, S parentheses t. It was the number of thousands of games that have been sold. Now, how do we interpret the result from question C? S prime parentheses 6 is the number 2. Well, remember that S prime parentheses 6 means the instantaneous rate of change of the sales. Now, what does that mean? Well, it's the rate at which the total sales are changing. But what does that mean? Well, it could mean a couple of things. One interpretation of this is there's one interpretation. We still have time t equals 6 months, and we are now talking about the interpretation of this number, the number 2, that is the value of S prime parentheses 6, which is an instantaneous rate of change. So that tells us that total sales are increasing at that rate. And notice there's my 2, and there's the unit that goes with the 2, and the other unit is the unit that goes with the time. The unit of time is months. So when I give the interpretation, I mention the units of the rate of change. It's going to be the units of S of t divided by the units of t. So 2,000 games per month. Now I said that's one interpretation. What would be a different way of saying this? Well, what does it mean to say that total sales are increasing at a rate roughly 2,000 games per month? Well, total sales is how many games you've sold up to that time. So if that total number of games is increasing, well, that can only happen by selling games. So in other words, the rate at which total sales are increasing is simply the rate at which the games are selling. I find a nicer description of this is the following. I like to say it this way. Games are selling at a rate of 2,000 games per month at that time. Let's go on. Question E. Use the results of D to estimate the total sales at 7 months. Well, how do we do that? Well, this goes back to the discussion of marginal analysis that we had in section 2.7. Remember, S prime parentheses 6 is the marginal sales at time 6, and it's interpreted this way. It's also interpreted this way. It's also interpreted as, in terms of the marginal idea, it's a good estimate of how much the total sales would increase if the time increased by 1 month. In other words, if at times 6 months a total of 30,000 games have been sold and games are selling at a rate of 2,000 games per month at that time, then you could safely estimate that at times 7 months, maybe around 32,000 games will have been sold. So that is, the total sales at time 7 would be roughly S parentheses 6 plus S prime parentheses 6. Now, we've actually seen this before, but presented in a slightly different way. Maybe I'll put the review in green. The exact change in sales from time 6 to time 7 would be denoted by this symbol, delta S. The approximate change of sales is given by the marginal quantity. So when we were discussing approximations, we had this idea. So we have this equation that says S parentheses 7 minus S parentheses 6 is roughly S prime parentheses 6. In other words, the equation that we wrote up above is completely the same as the equation that we had back in section 2.7 when we were talking about marginal analysis. Now that's all very abstract. We're actually supposed to give an estimate. So the estimate would be that at time 7 months, a total of 32,000 games will have been sold. So that's not dollars, it's the number of games, and it's in the thousands, 32,000. Question F. According to the model, roughly how many games will eventually sell? Now, this question is not asked in the book in any of these estimation problems, and I think it's too bad because this is sort of a blast from the past. This is asking, in other words, if we just let time go on and on and on, and the games keep selling, what will be the total number of games? Well, that means this question in mathematical symbols, asking what happens to the total number of sales when time gets bigger and bigger and bigger without bound. Well, let's do that. Let's do that limit. Now remember how we do these limits. We keep only the dominant terms. We only keep the leading terms in the numerator and the denominator. So we identify those leading terms. So we kept only the leading terms. We took their limit. Now, since the t is going to infinity, we know that t is not 0, so we can cancel the t over t. And we arrive at this limit. The limit of a constant is just the constant. So the abstract limit is 50. But what does that mean in terms of roughly how many games we'll sell? Well, S parentheses t is giving us the number of thousands of games that we'll sell. So in other words, the number of games that will sell eventually is roughly 50,000 games. Okay, let's go on. Question G says, illustrate the results of A, C, E, and F on the given graph of S of t. All right, well, let's go back up and look at those results. Result A was this, S prime parentheses 6 equals 30. That'll be illustrated by putting a point on the graph that has t coordinate 6 and y coordinate 30. And we should label the graph with the formula, 50t over t plus 4. So there you see is our point with coordinates 6, 30. It's right on this grid line where the coordinate is 30. Let's go up and see our result from question C. Question C, we found that S prime parentheses 6 equals 2. Well, that number is going to be the slope of the tangent line, the line that's tangent to the graph of S of t at t equals 6 will be m equals 2. So to illustrate that result, we should draw the tangent line and label it with its slope. Now what about the question E? Question E says the total sales at time 7 months will be roughly 32,000 games. How do we illustrate that on this graph? Well, notice that the exact sales at 7 months would be the point on the graph above that x coordinate of 7, or that t coordinate of 7. So on the graph, that would be this blue point. But what we found using the estimate corresponds to a point on the tangent line. So the estimate of the sales at time 7 months is this number, 32, which is across from this point on the tangent line. So we have two t coordinates, t equals 6 and t equals 7, corresponding to two different y coordinates on that red tangent line. And you realize that that y coordinate of 32 is an approximation. The actual number of sales at time 7, you can see, would be a little bit lower because the graph is curving down. So we could compute that value if we wanted, but the graph would get a bit cluttered. That's how we illustrate the results of questions A, C, E. What about the result of question F? The result of question F was that roughly 50,000 games will eventually sell, and it came from this calculation. The limit as t goes to infinity of S parentheses t equals 50. Now remember that that calculation corresponds to a description of a horizontal asymptote. That equation, that limit equation, that limit is 50, tells us that there is a horizontal asymptote on the graph on the right with line equation y equals 50. So let's draw that line. I'm going to draw it as a green line. So there's an asymptote. It's actually one of the grid lines on that graph. And so that is an illustration of that result from F. The fact that the games will eventually sell roughly 50,000 games is embodied in the graph by this idea. As you go off the right end of the graph, the y coordinates get closer and closer to 50. So that's the illustration of the result of f. Well, that's the end of that example, and that's the end of the video. Thank you.